Good afternoon, everyone. Thanks for coming. Appreciate the time, and looks like we have a pretty good house full of people here. So we're very excited to be here. My name's David Bader. I lead the go-to-market strategy for robotics and factory and warehouse automation for AWS worldwide. I'm super happy to be here and to work with Lockheed Martin. So today we're going to talk a little bit about robotics, but we're also going to talk a little bit about how we were able to, kind of tie together the IT aspect of a manufacturing facility with the operational technology, the OT side. So I think, as we go through this presentation, we'll talk a little bit about that, and that'll be the overwhelming theme across the entire presentation. So we will leave a little bit of time, hopefully, at the end of the presentation for questions. Hopefully they're very easy ones, and usually what we do when we have questions at the end is to volunteer for a question. You also volunteer to buy us a cocktail afterwards, so it's just an incentive. It's just something that I thought we'd win. So we'll go through some introductions. You guys want to introduce yourself?
How are you doing? Good afternoon, evening. What time is this? Afternoon, Vegas time?
It's evening in the East
Evening
Coast.
for most people, maybe?
Yeah.
Okay. My name is George Kaniamos. I'm the Director of Advanced Manufacturing Technologies and Operations Engineering with Lockheed Martin, Missiles and Fire Control Business Area. I oversee the advanced manufacturing, the manufacturing engineers, the industrial engineers, and a lot of what goes into building all of our products enterprise-wide within MFC. We build a lot of really neat things, and we solve a lot of really hard problems. Some of the products that you may be familiar with right off the bat: Javelin, HIMARS, F-35, Hellfire missile. Yeah, so that's us. Happy to be here, proud to serve. Look forward to chatting with you guys today. Yeah.
Hi, I'm Greg Doppelhauer. I am the LM Fellow and Chief Architect for Missiles and Fire Control. So as you can imagine, I have a pretty close working relationship with George and a couple of our other team members out here. And part of what I'm supposed to do for Lockheed, and let's hope I'm doing it the right job, is bringing technologies like with Dave into the factories, into our manufacturing processes to try and improve our yields, our outputs. How can I build 10,000 Hellfire missiles for the cost of 5,000? How do we improve all of our efficiencies across all of our manufacturing lines? And then when we do solve a problem for MFC, we contribute it back to the greater good Lockheed Martin. So, we build solutions at scale that can scale not just MFC, but to the size of our enterprise. So hopefully we'll nerd out here a little bit a little later.
So, the quick agenda, we're gonna go through. Anybody ever heard of the AWS working backwards process? Is that something that anybody's familiar with? Okay, so we'll talk a little bit about that. Doesn't seem like too many people are familiar with that. We'll talk a little bit about how we use that for this project in particular. Then we'll go through the actual manufacturing technology landscape and talk about the digital shop floor and how we kind of solved a lot of problems. So the working backwards process is really something pretty simple, right? But we live, breathe, and eat it at AWS, and it's about looking at a problem from a customer's perspective and then working backwards to solve a problem. So we never enter into a solution in the beginning of a customer engagement. We try to talk with the customer, we try to learn as much information as we can about the opportunity, and we work backwards from that opportunity to be able to come up with either a solution or a group of solutions that fit the process. And it's really not about solving the problem initially. It's about getting clarity on what the overall problem set looks like. And I went backwards. I had one job to do. So in this particular case, right,
we started backwards.
Yeah, working backwards. That's right. So in this particular case, we were really fortunate to be able to work with a digital artist, right? And we were able to take our learning that we had from a series of discussions with George and with Greg and with their entire team, and we worked with a digital artist to actually visualize this working backwards process. Now, we don't do this every time, right? But in this particular case, we did. And this is kind of what it looked like, right? And again, keep in mind, we're not trying to solve the problem at this point. We're really focusing on the what and the why and worrying about the how down the road, right? We're not solutioning anything. So the idea is to be able to do in real time is to be able to get these, these key metrics that are important to the operation and important to the IT team, all kind of, in one sitting in this particular case. And this is kind of what it looked like. So it was really pretty exciting to be able to do this process and to be able to say, hey, these are these important things and these are the North Stars and this is how we're going through this, as a team to be able to build this out. I keep doing it. Yeah, George.
I don't know. You rushed through that.
Yes.
Are you hungry?
I am. I'm very hungry.
Trying to get out of here early. Okay. All right. So Dave talked a little bit about the what and the why, and how we work backwards and how we were going through this whole process with AWS. Well, now we're going to talk a little bit about the how, because at Lockheed we have a lot of engineers. We like to solve hard problems. It's just usually what we do. You present us the problem, and we end up spending a lot of time and effort trying to solve it. But in the process of doing this how, we encountered that there were several different kinds of how. There's the technical how, which was, hey, how do we get this data from one database into another? How do we extract this information out of this machine and do something with it? How do we get the information to our technicians in a timely manner, get them the right information in a way or a method that they can actually interpret it and see it? How do we get some of our systems to talk to each other? Those were all the technical hows, and they were good discussions to have. We had them, we developed some roadmaps, we took some actions, we were able to do a lot of that. But as we moved forward in this process, we discovered that there were other equally as important hows that really drove challenges for us that at times could become roadblocks. Things that have to do with change management. Things that have to do with how do we upskill our organization to be able to deal with the tools that we're putting in place with them. I mean, yeah, we've got a room full of engineers here, likely, leaders in an organization. And what are we talking about? Well, we just digitized something. We made things easier, right? We put buttons in places for people to touch. That's easier, right? Well, not for everybody, let me tell you.
Exactly.
So the hows, as we worked through some of these hows, and we looked at the organization that we have, the organization that we need, we have a lot of commitments to our customers. If you look at the geopolitical landscape today, we have a lot of commitments to our warfighters, our allies, around the world. We can't stop production. And what are we talking about here? We want to put Spot in production at one of our facilities to be able to do work. So how do we start addressing some of those hows? How do we do that? So as part of that, next slide, we went through and we looked at our organization. How are we going to do this within our organization? And so we tried to leverage some of the roles that we currently had in place as part of our org. We had an organization already called the Advanced Manufacturing Technologies Organization. That organization is predominantly focused on research and development of new capabilities, manufacturing capabilities, robotics and automation, the materials, additive manufacturing, developing new manufacturing processes, and it's really where a lot of our operations fellows reside. In addition, we created an organization called the Intelligent Factory Framework, and I'll let Greg geek out later on what the Intelligent Factory Framework is at Lockheed. But ultimately, the intent of this group was to help find those strategic insertion points and to help be that closed loop feedback point to the AMT, our Advanced Manufacturing Organization, so that we're developing valuable solutions to the business that will actually drive change, that are what our technicians, what our workers want, what the business needs to drive the efficiency, the span time reductions, the quality that we need moving forward. So we also created another organization that kind of identifies the replication and the proliferation group. So this is a group that is predicated on taking information from this Intelligent Factory Integration team and from AMT, and how do you take ready now technologies and roll them out across an enterprise so you can compound your return. A lot of times what we find is no one technology or no one solution will actually pay for itself. You have to combine it with multiple other solutions and change your business process to actually make something matter and actually make change. An example, we do Lots of inspections, okay? Well, that's great. Well, I don't need to automate my inspections. I don't need to set up cameras to do inspections. Why don't I just use the IoT data that's on my devices to verify that I actually performed a task? Things like that. Needless to say, spoiler alert as part of this, right? I've gone through now, these last couple slides, and I never brought up our IT organization. That's just a spoiler alert. We'll talk about that next. Now, as we're going down all this, developing these organizations, trying to figure out how we do this stuff, our information group, our IT group, the AWS team, our partners, and part of my organization, as well as myself, went through and we started mapping out everything. We started digging deep into the details of all kinds of things. We were mapping out processes. We were developing value stream maps. We were creating systems diagrams. We were creating spaghetti charts. I mean, it was interesting and very insightful for me, because as an organization like Lockheed Martin, we have decades upon decades of tools developed over infrastructure, over processes that were created because we got a complaint or we found a defect and we didn't want this to happen, so we put a corrective action in place, and that corrective action wasn't very efficient, or whatever it is, it turned into a bit of a mess. So, lots of disparity, lots of complexity across the board. And what we ended up finding was 13 functional personas at the end of the day. And when I say personas, we mean roles and responsibilities, or roles within the organization. There were well over 15 process workflows, well over 16 software platforms that we're dealing with. And the reason we limited 15 and 16 is because we got feedback when we did these charts that if we added more, it's going to be too small so that you guys couldn't read it. So we ended up just truncating what that was. But this is what we were dealing with. And when we ultimately found this, we started having discussions, and it was more of spirited arguments over, why do you need access to my data? Why do I need to have an ERP integration when all this stuff is happening in my MES? Why do I need to integrate quality? Why do I need my corrective action request database to have access to anything that we have going on with Spot, for crying out loud, or warehouse management? Why does that have to be in here? On the flip side, our IT partners are sitting here saying, dude, you don't know how this operates. We need to be able to combine our data. We need to be able to have, the data format. We need to be able to clean our data. We can't apply, any of the models. We can't apply any of the things that we want to do to our data unless we clean all this stuff up. And then it hit me at some point, and it kind of brought me back to a conversation that I had with our IT leaders and our AWS partners, which was really surrounded around core competencies and silos. And this was exactly what was happening. And exactly what we vowed we wouldn't do, we were actually doing, and that was creating massive problems for us. And one of the reasons I'm bringing this up is because I know a lot of you are engineers, and we want to talk about, we'll geek out at some point, Greg will geek out on you. But I also know that there are many leaders in this group who might be running organizations. And this can really screw up your project if you don't pay attention to the other side of the house, okay? So with that, we went back to the drawing board. We had to get some of our leaders together and make sure that we took a more conscious effort at breaking down these silos, breaking down these walls. We started interviewing technicians. We started interviewing engineers together. We started mapping out processes and looking at solutions together. We started educating people about our individual roles and responsibilities together. And in doing that, we were able to break down all of these silos, and we were able to take this cluster blank of results and we were able to, we took a portion, I'm just showing you guys a portion of this, right? I mean, this was a much larger integration that we're looking at, but even something as relatively simple as views. What information does what person get at what domain or in what level of the organization to ensure that they can do their job effectively? And we were able to take all of those personas, all those processes, all those systems, and neck it down to 6. And look, I'm telling you, that was quite a feat, and we were really proud of being able to do that, because it really brought us to a point where we had a level of expertise and of situational awareness of our individual roles, and we were able to go back and look at what information do people really need to do their job. Do I really need a technician having our, getting reports on, quarterly, financials, for the company or for the center? I mean, is that something that they really need, or do they need more information related to the work that they have at hand and the work that they're trying to do day to day? And that's ultimately where we ended up. So that was, a positive note. Go to the next slide. Yeah. Okay, so our objective as part of this whole thing was to remove the data silos. We talked a little bit about that. Fill the data caps and remove blind spots. Now you'll know from the title of this chat or this discussion, we're talking about Spot, right? And so, we're really trying to figure out, how do we integrate Spot, and take Spot out of it and just put in X robot. How do we integrate this into our factory, and really trying to figure out how do we fill in some of the data gaps that we may not have or may not have a solution for, and how do we do that autonomously? And then, of course, improve the quality and the overall productivity of our workforce and of our technicians. And for us, at least at some of our sites, we have a unionized workforce. So that becomes a challenge. And so really trying to help people understand that this is not about removing jobs. This is not about people's jobs going away. And it's about augmenting a person's role. It is about helping support and perform activities that will make somebody more efficient. And it took a little while for us to get there. But when we were able to demonstrate that to our workforce, we started to get buy-in from them and from leadership within the union, so that they could understand that this is not about, this robot is going to go off and do their task. That wasn't what it was. We just discovered that there are a lot of tasks that people do day in, day out that take a lot of time when you start aggregating it over a period of time. And if we can start reducing some of that, we can start impacting spans, we can start impacting tack times, we can start impacting the quality, we can start impacting, how many hellfires we can get out the back door when the customer needs it. So that's that in a nutshell. Okay.
Yeah. So part of the thing that Lockheed has done, very progressively is to connect their machines, right? So this process, and Greg will get into this a little bit more detail, but being able to connect and to have visualization into all of this data really made this process a lot more kind of coherent. We were able to see things a lot more clear. So in this particular case, as we kept boiling things down, we looked at the really big picture and we said, okay, at AWS we look at, we start big and we take small chunks, and that's how we approach most projects, right? So we boiled it down and boiled it down and boiled it down. And what we all came up with as a group was that the CNC model, machine optimization was kind of that low-hanging fruit, right? So at this particular facility outside of Dallas, there's 70 CNC machines, all in one very, very large manufacturing area. And the idea was, how do we help that process flow? So if anybody has CNC machines in their facilities, they may have 5 or 10 or 1 or whatever, and being able to move material in and move the finished material out is not that big a deal. But when you're talking about 70 machines, in one facility, and being able to get that material flow and automate that without conveyors or without augmenting the facility was a challenge. But we decided, hey, that's going to be that low-hanging fruit. That's what we're going to go after, and that's where we came up with the concept of Spot. Right? The idea was Spot can kind of overcome some of the facility kind of difficulties, like uneven floors, and there was actually wiring trough and plumbing trough in the middle of the facility. Could we have built a large IoT structure in the building? We had 120-foot ceilings in many cases, so being able to mount cameras or do other things became a real challenge. So we decided that we were going to augment the material flow. And oh, by the way, we identified that in these 70 machines, there were upwards of 15 per day tooling breaks. Right? That's where somebody had to leave their workstation, walk God knows how long to a tool replacement location, wait there until the guy reset the tool, and then walk back. that machine was down, that operator wasn't doing anything at that time. So we augmented their process by implementing robotics in the CNC process.
So good, fine with me.
That's you.
So a couple of things that I want to piggyback on George before we get some of my stuff. Most of you probably think of your manufacturing facilities as we build one thing. Trouble with us is our manufacturing facilities, some of them are 100 years old, and some of them build 10, 15, 20 different products or pieces of the product. So that adds a layer of complexity to what we were trying to do as well. The disparate nature of each of these facilities and their ability to provide product where we needed it, when we needed it, at the right time. So in this chart, we're going to start talking about how we started our journey. And it's really interesting. If anybody here from 2018, reInvent 2018, saw me talk about the Intelligent Factory Framework that we built at Lockheed Martin? Oh, and Adam, you were there. So back in 2017, we undertook a task to build a network fabric and a framework that we call the IFF that allows us to connect our machines and protect not just the IT infrastructure, but the OT infrastructure. The best way I can describe it is it's a very secure private cloud that runs inside of Lockheed Martin that all our machines are connected to. And by presidential mandate, Steve, if I'm not mistaken, if you work in the DIB, you have to provide this level of protection and complexity to the tools that you're running in your facilities to build.
Defense Industrial Base.
Yeah, okay. I'm sorry. If you work at Lockheed Martin, or probably most of the DIB, you're going to be dealt with a ton of acronyms. So if I hit an acronym you don't recognize, just shoot me. So reality, if you look at this chart, I mean, we may sound like we're mature. We're just starting our journey. It's a long journey. And it's one that we've had to build upon our successes, keep going back to leadership, saying, here's the next step, here's the next step. Here's how we take it to the next level. So the funny thing is we're bringing in Spot, we're bringing in a couple other different types of robotics, and we're laying it right into our Intelligent Factory Framework. We have no infrastructure work to do whatsoever. So we've laid the base and we're moving towards full automation. It's the next one.
Yep.
It's you.
Yep. So if you've ever implemented a mobile robot, and probably some people in this room have, and if you haven't, we kind of start by identifying the area in which the robot is going to travel, right? So in this particular case, we had a very large area. We had a very uneven environment. So we took an overall view of the space, which you see here in the picture, and then we started to drop in, like the tool drop-offs, the tool pickups, and those kinds of things. So we dropped those in, to be able to, kind of get a picture and to communicate that picture to the team. So George talked really well about the idea of talking with the unions and making sure everybody's on board. Anytime you implement a robot solution, especially a mobile robot solution, it's really important to be able to communicate to the teams what to expect. And so by being able to do something like this in a kind of a graphical format, although it doesn't look super sophisticated, maybe it's probably not the best 3D CAD drawing anybody's ever seen. But being able to take this and have an internal meeting with the operators and say, hey, this is where you're going to have a tool dropped off for your machine, or this is where a tool is going to get picked up, was a really big deal. And it really it made an impact on the operators. They all of a sudden became part of the process rather than like a cog in that wheel.
All right, so now we're going to talk about how we brought them in, right? So this is really interesting. We have the Intelligent Factory Framework established. Okay, now we're going to introduce this new device. So now we're partnering with George. We had to go to George to get the money to buy it first. So, hey George, got a few bucks? And it's interesting, right? I think we developed the relationship that I think we've established here in MFC is unlike any other in the corporation. We have a pretty good relationship that allows George and I and Steve and Matt and Jonathan out here in the audience, the rest of my team, to really have hard conversations, have some interesting conversations about security, George's team once in a while wants to go out and say, hey, look at this new thing I bought, without any concept of how do I put it on the framework, how do I introduce it to the manufacturing facility, how do I securely bring it in. And when I say secure, the biggest concern for us is not just north-south movement, east-west movement. Many of you probably heard the Honda use case and a couple others. Lockheed wouldn't stand this up until we could guarantee that we would not have an incident that happened at Honda and some other manufacturing facilities. So taking this a little further, we said, okay, now we're talking to Dave, right? Dave, how do we take, and if you've been in a manufacturing facility with MES instructions and all the things that go into building something, you've got work steps, you've got log on to standards, you've got all this other kind of stuff going on. And in the meantime, I'll take an example I think we used as part of JASM, it was JASM. We have a welding operation. Takes the welder 2 hours. Clocks onto that job, performs the job. He or she then has to go find, not notify, go find an inspector. After that inspector comes in, they log my user out of their manufacturing execution system. They log in, find the work step, and then they execute the inspection. When they're done, my welder has to go log in and begin the same process over and over again. As you can see, we've got a lot of time-consuming steps. Yeah. So working with AWS and one of their preferred partners, Tulip, we started looking at process automation software. How can we take steps out of the process that are redundant, unnecessary, and still maintain the level of security that we need to make sure that it's Greg doing the welding operation or, George doing the inspection. So we're looking at Tulip to come in and be that glue that stitches together our process automation with our back-end MES, with our back-end WMS. There's a whole, it's not just your MES, it's your ERP, it's your WMS. And if you look at the way we build things, it required us to think about the integrations across major enterprise systems. So working with Tulip, we're developing not just these automation screens that are just touch button or touch screen and red lights for notification or even SMS, text messages for notification to inspectors to come do a job. I may not even have my inspector log in anymore. They just come, hit the inspection button, and we move forward. So there's a lot of things to look at outside of just the robotics going into the factory. We were looking at process automation as well. Because if you look, I think I counted, probably 2 hours worth of wasted time a week just logging in and logging out. So how do we take and minimize that activity? So we're working that with Tulip, which is would you call it SaaS? It's something that's available in the AWS marketplace.
Yeah. Huh? So I think the key there with Tulip or with many of the AWS partners is that using a service like this, we were able to take all of those disparate software systems that you saw in the earlier slide and kind of connect to all of those, and then be able to bring that out to to make sure that we're saving time, but to also be able to collect those those kind of operational things that are going on, so that we can then continue to change and continue to iterate. So being able to tie all of those systems together in one format, I think, was a real key to this overall solution here.
Yep. So what do you got the next slide?
Yep. So this is you.
Yeah. So Greg already covered most of most of what we want to do here, but so Tulip. Hey Greg, look at my new shiny penny. I want to integrate Tulip in the factory. So Tulip's been a great tool for us thus far. We've done several demonstrations with Tulip. We're working to try to figure out how to get that integrated. We've been working with our corporate information security team, who's going through and doing their analysis. They're super outgoing and flexible people, which has been super helpful. That's total sarcasm. And so
on video.
Anyway, it was Tulip brought forth a low-code, no-code solution for our manufacturing engineers. Because as we talked about earlier about bringing in new technologies and are people familiar with them, how do you upskill people in various domains so that they can use the tools that you're putting in front of them. The Tulip brought to the table a way for our engineers to bring their creativity, citizen development, if you will, and help them work to manage certain processes in the factory. So by giving them the tools to be able to take sensors, find sensors, go buy some sensors, integrate a smart workstation together, and put the controls in place for the manufacturing processes that you just wrote work instructions, right, for a technician to perform. And allowing them to be able to do that, was very helpful. Was very helpful. So
I think one of the things we're working on too, George, is that your team can do those low-code, no-code modifications to the process.
Yeah.
And instantly make an impact in the production area. It doesn't go, we still follow a DevSecOps procedure and a deployment, but his team can now recognize an efficiency and implement it in Tulip in a matter of hours as opposed to days, weeks, or months it previously took.
Yeah.
Without tying up a developer, which is rare.
It's coming at a premium.
Yep.
All right.
When the heck are we going to talk about robots?
Yeah. I think this is where you guys really wanted to get, right? I mentioned already that, in 2018, I'm trying to remember when the world shut down, right? It's 2018 or 2019.
2020.
Came out here, spoke 2 years in a row about the work Lockheed's doing with IFF and IoT Core. I think the biggest benefit for us was AWS IoT Greengrass, the ability to push edge compute onto our network fabric, the IFF, and then begin to traverse the network fabric to our data lake in AWS. I think we're hitting somewhere around, correct me if I'm wrong, Steve, 75 petabytes of data today coming off our machines. We're working now with some of the citizen data scientists and some of our other data scientists to figure out if that's 75 petabytes. If I've got 200 tags on a machine, do I really need all 200? What are the top 20 that really give me value? So we're really trying to narrow that down and get to a point where we can say, okay, I've got 20 tags on every machine that drive value, and then we're going to build models and we're going to build dashboards and displays for leadership so that they can understand what we're doing. I talked about the extensibility and the strong security. That's, successful machine connections. Let's see, I think one of the other interesting things, all you guys have heard Greengrass today and around here today and a couple of things I was in, a really great job at OPC UA, really great job with MQTT. Well, the higher ups in Lockheed Martin decided on a format called MT Connect. It's a whole lexicon around observations. So we decided on that. So the first thing I had to do was write a normalization that takes all these tags that come off the machines and turn them into MT Connect format. So as many of you know, Greengrass runs at the edge. I run a Lambda at the edge that takes and turns that JSON object that we get, because we can't send straight OPC UA across the network. Lockheed won't allow us because you can't encrypt it. So what we do is we put it in an HTTPS packet in a JSON object, and we send it up. So what I needed to do was normalize that data, or figure out how to normalize that data. So a little Python program I wrote 2-3 years ago, still running today, I think, and then they've turned it into, I think we have a Java one running as well. So there's a lot of really interesting things that we do at the edge to get the data in the format we need. All right, so how does our IFF work? And then you can see our IFF along with Spot. We've added Spot down at the bottom, but most of the IFF today is CNC machines, even machines that don't have any sensors on them. Think about that. We had metal shearing machines that we needed to know what the usage was. Strictly an analog machine. You push a button, drops a shear, cuts a piece of metal. Worked with a couple of vendors. We're able to determine when that thing was in operation and when it wasn't. So if you look at the stack here, we come up from the edge, and everything is based in IoT core services. There's some, I think it's funny if you, this may not be known to everybody, but I think we're one of the largest Kinesis users in the world. because every Lockheed Martin PC has forensics on it, and it streams through Kinesis. So, we not only stream our IoT data, we stream all of our information about our corporate assets. So as you can see,
Everybody's going to know that now, by the way.
I'm sure they knew it anyway.
Yeah.
As you can see, we execute a lot of services, right? We've got IoT, site-wise, we started implementing this year. That's been a little bit of a challenge, but we're working through it. Site-wise is a very complex product for visualization of what your factory looks like. Works as a graph database in the back end. You can develop functions and real-time visualizations as data's coming in. So it's been a little bit of a challenge. I think our team has struggled to skill up in that area, but I believe there's a lot of power in the tool. So we're gonna continue down that path and see if we can get to a really steady state that allows us. Are you trying to rush me along here?
No. Yes.
Really gets to a steady state. Wait a second, how much time we got left?
You got 20-some minutes.
So yeah, we're good.
He's hungry, that's why he's.
But I mean, you can look at all the services, right? There's a set of streaming services. There's a set of data services. There's a set of analytics services that all are being put into use, all based on the Intelligent Factory Framework. And now we're just adding Spot and robotics into that. So we're going to communicate with Spot via some of these tools here. You're going to see in the next slide or two. We're also going to use some of the tool APIs and data functionality and connectors to be able to direct Spot along its merry journey in our plant. So if you go to the next one, Dave, we can talk about the deep dive here.
No, this is...
this is George.
Yeah.
There's no deep dive. Deep dive's on the next slide, I think.
Oh, okay.
I guess. Okay, North Stars, technical KPIs, OEE. I'm not going to belabor this one, but ultimately at the end of the day is what makes this real for us, right? It was really machine availability, insights, simplification of the process, shop floor quality, shop floor management, ensuring the factory has the information that it needs to be able to perform work, and that it gets that information in a timely manner, in a format that can be consumed, so that our technicians and that our workforce knows what to do, and they have the information that they need when they need it in a way that they want to see it. So
I think my takeaway on this one is it's very easy to say, hey, OEE, right? Let's do some OEE. But when we start to talk about what Greg, and his team built, and what George wants to see, we have to start at that beginning piece and build that whole infrastructure so that we can then be able to do these kinds of things and get to those top priority KPIs and ultimately get to OEE, right?
Yep. And I think it goes back to our MES, right? We got to be able to communicate with our MES to provide that sensitive data that we need. Yep. The other issue that I don't think George talked about that he always likes to say, and I'm going to steal his thunder here.
Go for it.
Is think about our products. Okay, everybody knows the F-35. It flies and comes home. 90% of the products, 99% of the products we build don't come home. We don't get a chance. We don't get a second chance to make sure they work.
Yeah.
So you ask why so much testing, why so much test data, why so much rigor? We only get one chance for these products to work and work work where they need to work, not in the hands of our men and women or the U.S. or our allies warfighters. So it's an extremely sensitive
and important
thing that we undertake, and I like to brag and say we do a pretty damn good job of making sure that things go boom where they're supposed to go boom.
Yeah. Not here, just saying. So by pulling together, like how did we do all of this, right? Where does AWS fit into this, right? We talk about some of the services, but what we did was we have an advisory team, right? We have a manufacturing advisory team that's part of the ProServe team. They came in and they worked with the Lockheed teams to come up with those high-end systems, right? That's how we discovered the 15 plus or 16 plus, disparate software systems and the numbers of personas. So we brought in an AWS advisory team. We also had our ProServe team, right? So our ProServe team comes in and says, hey, we can build the data lake with you to make sure that all of the data is going to the right place and it's structured properly. And then also we talked about partners, and we talked about Tulip. So the idea is, in this particular case, it was a community of efforts to get us to be able to build something as simple as deploying a robot for delivering parts to CNC machines, right? So we could talk about the robot part, and we will a little bit, but the idea is all of the infrastructure and all of that capability to be able to build that securely and robustly, and then be able to replicate that for the next robot or the next process. So I think it's really important, and we have this slide here from Tulip to show that there's dashboards and there's interfaces and all of this stuff in that we are adding into the overall system. But again, keep in mind that we're tying all of those disparate systems together so that now we don't have to worry about people drilling into each one of those systems separately to do their work.
And I think the other thing we did is we called you guys in and made you a partner in our strategy, right?
Exactly.
We had, early on, we had some meetings, I think after the world started opening back up, I called Robin and probably half her team down to Orlando and half of my team down to Orlando, brought in George, brought in executive leaders from the business and said, what moves the needle for you? And I think a lot of those discussions spurred a lot of projects. I mean, we're working machine learning, we're working edge compute with Spot, we're working a whole ton of solutions to improve our yield across our product line. I mean, I don't think we've not looked at a probable solution for some of the things that ail us, and
That's right.
I think it's been a really successful relationship now. We haven't gotten to half the things we want to get to, so look for us to be here next year to talk about something we sell.
We will. I remember that meeting because George started that meeting by saying, damn it, I want robots in 2 weeks. I want a whole mess of robots in my facility. And it was the first time, I think, in George's career that an older guy said to him, no. I said, no, we're not going to put robots in here until we understand what the business value is. And then he called Robin and said, hey, who's this guy, this robot guy that you brought in here telling me no, I want robots? And we worked through it and we developed this process. And I think that now we can start adding more robots and adding more things in a kind of a sprint fashion, the way you would do software.
Yeah, right? I think the thing that stuck with me the most out of your conversation, and I think it really shed a light for you guys, was he came in and said, we do the hard things really well. Yeah. We do the easy things really, really hard. So we need to fix that problem. And this is part of fixing that problem.
Yeah.
So where does Spot fit in? That was my only line on that last issue.
So, okay. Now here we get, how do we get a Spot in here? I'm going to hurry up because we have 17 minutes left. But again, we talked about IoT Greengrass, right? You guys know that, we're going to connect through IoT Greengrass. We're going to put it on that fabric. All the edge data, we've selected a few different payloads for the back of Spot, and the payload on Spot is a different functionality. We've got an arm, we've got a camera, a couple other things, some edge compute. I'd really be curious to see if we could run Greengrass actually on Spot. That's one of my next,
And we've done it.
Yeah,
it exists, yeah.
So I think if you look at the stack here and the capabilities here, everything we want to do is possible. It's just stitching it all together and getting Spot to fit into the scenario. So let's go to the next one. I think there's another one that talks about, as we build this up, I mean, this slide's going to build, it's going to get geeky on you, right? We're going to use IoT Greengrass. We're going to use the developer kit, the Greengrass developer kit at the edge for some API management at the edge and the communications with Spot. We're going to be telling Spot right at the edge what to do, when to do it, sending instructions to the APIs that exist on Spot as they come from the manufacturing systems. And then you're going to see the data traverse up through Greengrass coming into, we're going to be we send recipes now through Greengrass in some other ways, but you're going to see data and artifacts come up from Greengrass as well. It's bi-directional. And then we're going to push inference. How can we start to use Spot for some of the things? Inspection, machine learning, visual inspection. The capabilities that we get in that upper right-hand box become limitless when you look at your business process and where you can improve. We have a business, I won't mention where they are or what they do. It's very sensitive what they do. It's a lot like chip manufacturing. Their yields are 25%. If I can increase that by 20%, that gives me to 30%. I add another B to the end of that business. So that's one of the things we're going after as well. How do I take machine learning and learn earlier in the process when I'm going to fail? How do I relate that failure back to the process and then take that failure out of the process?
And I mentioned earlier that the buildings that we were talking about are, unlike many of a standard manufacturing site, right? So think about 120-foot ceiling, a hangar, an airplane hangar or something like that, where it's not easy to put in cameras and infrastructure with wiring and all in that kind of environment. So being able to put this on a robot and do the inspection in a mobile fashion is really kind of innovative for this business.
Right, and I mean, we're sharing some information with our Aero partners. Adam's sitting right here from Aero, Digital Transformation Senior Manager. We're sharing some information with them, everything we're doing with Spot. So how do we move this work to the F-35 line? How can we improve processes on the F-35? And then we'll go from the F-35 maybe to Sikorsky. How do we go help Sikorsky? Then how do we help space, right? It's not about MFC, it's about Lockheed as a whole. So everything we build, the IFF is a Lockheed Martin enterprise system, right? Everybody can build on the IFF. We're just stepping in, we're stepping out first. So we're leading the corporation in developing Aero does some robotic assisted inspection. I'm not going to say they're not, but they're dealing with some very, very proprietary technologies. Here we keep it as agnostic as possible. I could plug in tomorrow, if Spot comes out with Spot 2.0 tomorrow, I could plug it in much easier than if I were working with a proprietary technology.
And I think you said it earlier, it's not, Spot isn't the message here, right? Spot is a great partner. Boston Dynamics is a great partner for AWS, or a great customer for AWS. But it can be any kind of robot, right? Any kind of mobile robot. The same kind of process holds true. In this particular case, Boston Dynamics is the right solution because, as I mentioned, the floors and all of these other things. So yeah, it's pretty exciting. And everything that Greg said, we're super proud from AWS perspective to be a part of the IFF and to be a part of all of this data gathering. So it really makes us a true team because that it's all built from that ground up.
Like George talked about the geopolitical climate. Those products are performing well. So we have to make more, but we can't make them. There's no additional cost to make them. So my customer not only wants their things faster, they want more of them faster. And the only way we're going to get there, process improvement, process automation, nothing is off the table. So we have to start using the technology to help us get there. And again, this is chart just to show everything we built, we're building to scale, right? Everything built with DevSecOps in mind. Everything we do from a robotics perspective, we can deploy multiple places. Everything we build from a tool perspective, we can deploy multiple places. Even we're going to even force the teams at the edge. George's functional folks, Aero's functional folks, they'll have the ability to do these things and make the changes on the fly. We'll build the automation for them. Just make your changes and let's process it. So I think that's the key message I want to get across here is it's about building a solution that scales, not just to your business, but to other areas in your enterprise, and being able to build it on tools that can support the scale.
That's right. Oh.
All right. You going to introduce?
Yeah, so we brought Spot out for the first time, and we kind of mapped an area. We did a demo where we used machine learning initially. So this is the environment in which Spot will work. In some cases, it's not particularly the CNC area, but this video comes kind of self-explanatory. It's available, everywhere. Don't pay attention to that guy in the back on the phone in that particular
Nobody
picture.
saw that until you.
Yeah, that's what I'm saying.
I think this was released. We released this on National Dog Day on LinkedIn.
Yep. So there was National Dog Day, so the Lockheed put this out as a public support to pets. So we'll just let this run, kind of understand what's going on.
Lockheed Martin Missiles and Fire Control operations team collaborated with Amazon Web Services to reimagine how we work and demonstrate how the Boston Dynamics Spot the Robot Dog can help us transform our Grand Prairie operations to generate products faster and easier. During the demonstration, Spot showed the team various interactions and scenarios to explore automation on the operations floor, like material delivery. Spot will benefit manufacturing operations by augmenting our existing workforce and supporting people's day-to-day monotonous tasking, allowing our employees to focus on the critical aspects of their roles, ensuring we are meeting customer needs and manufacturing quality products. AWS tools provide machine learning and Internet of Things capabilities that enable predictive ordering and direct Spot to inspection tasks to keep the facility running smoothly. Together with AWS, Lockheed Martin is revolutionizing our factories, tools, and processes to enhance production, answering our customers' needs, and delivering mission success.
And all those black boxes you saw on the back of Spot, there's a ton of them, right? There's a ton of options.
Right.
But Dave can go into more, their payloads.
Yeah, yeah. So we have a little bit of time left. We'll be happy to take some questions. And then if we run over from a question perspective or what have you, we can meet you out in the back as well and take some more questions, or if you don't want to stand up in front of everybody. But we'd love to hear if anybody's got any thoughts or comments or anything about the overall discussion.
Hopefully
Hopefully it was helpful.